Hello, geometry students. These are the main points of lesson 4-5 on isosceles and equilateral triangles. Talks about triangle classification by sides. You know, a scalene triangle has no equal sides. They're all different lengths, all three. Isosceles triangle, at least two equal sides. Equilateral triangle, all sides are equal. You should note this, that an equilateral triangle meets the definition of isosceles, at least two equal sides, so it's also an isosceles triangle. However, the converse of that is not true. An isosceles triangle does not meet the definition of an equilateral triangle because only two sides are equal. So if it's equilateral, it's also isosceles, but if it's isosceles, it's not equilateral. And classification by sides is one of the things that we do with triangles. The other is classification by angles in the triangle. And an obtuse angle, you know, has an obtuse triangle is one that has an obtuse angle. And then a right triangle has a right angle. In an acute triangle, all three angles are acute. Equiangular, all the angles are equal. And in a triangle, that means they're 60 degrees, right? Because if you have three equal angles in a triangle where all the angles have to add up to 180, 180 divided by 3 is 60. Now, we classify triangles in a way where we take one word from the sides list and one word from the angles list. All right, and you can see this one up at the top is an obtuse triangle because here we have this obtuse angle right here. And as you can see, you can only have one obtuse angle in a triangle, right? Because if an obtuse angle is over 90 degrees, if you had two of them, you'd be over 180 total, with one angle still to add in. So it has an obtuse angle, and all three sides are different lengths, so it's obtuse scalene. Now I want to talk a little bit about this next one. This is an isosceles right triangle, because the reason I want to talk about this is that some of you are really being bothered by this on the proficiency. You're having a hard time picturing the isosceles right triangle, and seeing that, okay, two sides here are equal, so it's really, you could call them both by the same variable, and that's the hypotenuse. So when they tell you it's an isosceles right triangle with a leg that is 8 centimeters or something like that, well, that's these two that make the right angle, not the hypotenuse. The hypotenuse is not one of the two equal sides, because it's always got to be the longest side. And you can't have two longest sides. Okay, so when they, in the proficiency on the Pythagorean theorem, don't get that mixed up anymore. This is what they're talking about, a triangle that looks like this. All right, so we would classify that as a right triangle, and it's also isosceles. So this is a right isosceles triangle. All right, you can see that the bottom one also has its two of the sides marked equal, so this is also an equilateral triangle. But what about the angles? The angles are all acute, so it's acute isosceles. Alright, so when you classify triangles, you use one word from the angle list, one word from the side list. Alright, some of the main points in here. This first question says, in figure 1, why is angle A equal to angle B? Alright, and what you're going to learn in this particular lesson is that theorem 9, which is stated right here, if two sides of a triangle are equal, the angles opposite them are equal. So the angle opposite AC is angle B, and the angle opposite CB is angle A. So these two sides are equal as they're marked. That means the angles opposite them are also equal. Right? So keep that in mind. That's theorem 9. And you're going to hear theorem 10 in a minute, which is the converse of that. What type of triangle is triangle ABC, classified by angles and sides? Well, as you can see, it's an acute isosceles triangle. Two sides are equal, and all the angles are acute. And now we also know that because of the two equal sides, that the angles opposite them are equal. You're going to use this theorem 9 a lot, also theorem 10, which is coming up here. A couple things about equilateral triangles. They are equiangular. We talked about that on the previous slide. Because if all three sides are equal, then the angles opposite them have to be equal. So if I have this isosceles triangle with all three sides equal, well, the three angles are equal also. And you knew that. They're all 60 degrees. So, yes. The converse is also true. If a triangle is equiangular, it is also equilateral. Alright, what's true about the side lengths of a scalene triangle? That's just to make sure. That's the one that we don't talk about as much, but that's what most triangles are, sides that are all different lengths. And then, the last thing that we want to talk about here is Theorem 10. In Figure 2, why does xy equal yz? Well, what's the information that we start with here? We start with that these two angles are equal. Now in Theorem 9 we started with two sides are equal, so the angles opposite them are equal. Now we're saying that in this triangle, these two angles are equal, so the sides opposite them are also equal. Alright, so side opposite y is xz, and that one equals the side opposite angle x, which is yz. So Theorem 10 is the converse of Theorem 9. If two angles of a triangle are equal, the sides opposite them are equal. Alright, now, how do you know which one to use? Well, there again, you have to look at what information did you have to start with. If the information that you have to start with is that AC equals CB, that the two sides are equal, then you use this one right here. If two sides of a triangle are equal, that's what you've got, right? That's the condition. You've got two equal sides. Then the angles opposite them are equal. So if you're starting with two equal sides, you're using Theorem 9. If two sides of a triangle are equal, the angles opposite them are equal. And then in Figure 2 here, what are you starting with? You're starting with the angles are marked equal. Alright, so then that's when we use this one. If two angles of a triangle are equal, the sides opposite them are equal. Alright, now that should get you through 4-5. So we will get to the homework here as quickly as possible. Have a geometric day.